Today we're going to go into the details of graphing a rational function. You've already seen the left, right, up, down, but that's when the rational function looks a little bit more plain than these do. So as you can look at this paper, you can see these are all rational functions, which means there's a variable in your denominator. So let's go through the parts. There's several parts that you have to find, and here's your list, obviously right here. We're going to find both kinds of intercepts, x and y, the horizontal asymptote, the vertical asymptotes, you might have more than one, and then any holes. So there's kind of a lot of steps to this. So we're going to go through them kind of one by one and then put them all together. So in order to find the vertical asymptote, all you do with this is you're going to set the denominator equal to 0. Because basically in a polynomial or any fraction that has a variable in the bottom, the denominator rather cannot be 0. So we're trying to find all those places where that might happen, and then those are the places, these are your asymptotes because the graph doesn't exist there because you cannot divide by 0. So we don't care about the numerator, all we care about is the denominator. So we're going to take x squared minus 1, set that equal to 0. So we get x squared equals 1, and when you take the square root, you get x equals plus or minus 1. We would then go to the graph, which we'll do here in a minute, and we would go, okay, here's where x equals 1, that's an asymptote, here's where x equals negative 1, and we draw those two asymptotes on there. As you know, the asymptotes help you draw the graph. So that would be your vertical asymptote. So again, here in this next one, x minus 1 equals 0. So here we would have only one vertical asymptote. And when you write the vertical asymptote, a lot of times we'll label it vertical asymptote. But again, it is an equation of a line. So you should have the letter, the equal sign, and the number. And just one more example of a vertical asymptote, x squared plus x minus 6 equals 0. There's a lot of factoring that comes involved with these rational functions. Here's an example of one. So we need to multiply to get 6 and subtract to get the 1. So that's a positive 3 and a negative 2. So here we would get x equals negative 3 and x equals 2. And then we would draw these two lines on the graph, and that would help us draw the function. Now the horizontal asymptote is the one that runs left and right. You're only going to have one of these in your equation. So the way this works, and so we can just tell by looking at it, honestly. There's not a lot of work here. There's only a few answers. So let me find a place to write this. Of course, I didn't give myself much space. We'll go over here. You're looking at the degree. So if the top degree is greater than the bottom, then you don't have one. No horizontal asymptote. So again, we're looking at the highest powers. If the degree on the top is less than the bottom, then it's always the same. It's always going to be y equals 0, which is the x-axis. If the degrees are the same degree, then you do lead coefficient divided by lead coefficient. And I'll show you exactly what I mean by that here. So in this, our degrees, the highest power, top and bottom. So here we have the degree on the top is smaller than the degree on the bottom. This is automatically the line y equals 0, or right on that x-axis. You don't have to write them both, but I know sometimes the x-axis is a little bit easier to state. So be careful with this. You are looking for the highest power. It doesn't mean the first. So as we look through here, the highest power is x to the third, and the highest power here is x to the third. So I'm going to rewrite this a little bit just so we can take a look at it a little bit better. So we have x to the third, that's a 1x to the third over 5x to the third. So what happens is these x to the thirds are gone. And remember, this is really y out here. So then this is y equals 1/5. That's what I mean by this. Lead coefficient divided by lead coefficient. You basically get rid of the powers just on the highest power, and then you just write that number that you get. A lot of times it works out to be a 1. But that one, of course, we get a weird fraction. That wouldn't be hard to graph because that fraction's so little. Now for number 6, again, we are looking at the degree on the top and the degree on the bottom. The degree on the top is smaller than degree on the bottom. This is the one that happens most of the time. So this is, again, the x-axis. We don't care that it's negative. All we're looking at is the power. So the first degree, second degree on the bottom. This one, like I said, probably won't happen to us very often, but just in case you're wondering what if it did, it won't. But if that's true, we would just not have a horizontal asymptote, which means our graph would look kind of weird. Now for the x and y intercepts. This is the standard definition for x and y intercepts. So for the x-intercepts, we're going to set the numerator equal to 0, just to kind of give you a short version, short directions. For the y-intercept, definition of y-intercept is make all the x's 0. So that's what we're going to do. All x's will become a 0. So for this, for the x-intercept, we're going to make the numerator only, set this numerator equal to 0. So 3x squared minus 12x equals 0. These have a 3x in common, leaves you with x minus 4. So we get x equals 0 and x equals 4. So these would be the two places on the x-axis that you would have to put the points. For the y-intercepts, we're going to make all of the x's equal to 0. So this is still y out here. This would be 0 minus 0 on top of 0 minus 0 minus 3. So 0 over 3 would mean our y-intercept is right at 0. It's just practice so that we know what we're doing when we go to actually do this for real. So again, I always label this stuff x-intercepts, which means takes the numerator, set it equal to 0. This is going to have to be factored. Multiply to get 6, so negative 3 and a positive 2. And then we get x equals 3 and x equals negative 2. And for the y-intercept, we have y equals 0 minus 6 on top of 0 plus 7. These are the actual numbers, so right here. So our y-intercept would be negative 6/7. So let's put all this together. I would strongly suggest that you stay organized. You will always be asked for these parts, so be prepared to find them all. So again, here we go, one more time. Finding the x-intercepts. The x-intercept is to take the top and set the top equal to 0. So top equals 0. So here we get x equals negative 4. So I'm going to put that on my x-axis right now. So on the x-axis, 1, 2, 3, negative 4. The y-intercept means all x equals 0. Put all x's equal to 0. So we're going to have y equals 0 plus 4 on top of 0 minus 6. So we get y equals negative 4 over 6. So y equals negative 2/3. So approximation. Vertical asymptotes. Set the bottom equal to 0. Negative 2x minus 6 equals 0. This is a line. So draw the line on the graph at x equals negative 3. This is a dotted line. If you do not draw your asymptotes, then your graph is not complete. Horizontal asymptote, remember we look at the degree. So we're going to have y equals, we have the highest power is that on the top, and then this on the bottom. So they match. So when they match, we do lead coefficient divided by lead coefficient. So we basically get y equals negative 1/2. This is going to be a little hard to draw because I have that one fraction, and now I have another fraction. Negative 1/2 is a little bit bigger. Whoops, it's close enough. Now the idea is you have the points and you have the lines, you should be able to draw the graph. So we can see that this graph has to live in this section. Don't touch or cross your asymptotes, but there's that part of the graph. And you know that most of the time these live diagonally from each other. And so the other one clearly has to be up in this quadrant or this part of the graph. It goes a little bit below the x-axis, and then it has to go through that intercept. So between the intercepts and the asymptotes, that should be sufficient enough information to draw your graph. Now we have one more thing about these graphs. There may actually be some holes in the graph, a tiny little hole in the graph that you'll have to actually draw in yourself. If you use your calculator, the calculator does not show these. So you'll have to know where it is. A hole comes from when you have the same factor on the top and bottom. So you'll have to factor each, right? So it says numerator and denominator. So it must be removed. So we factor the top and the bottom, and we're basically looking for a common factor. So this has an x in common. And so here is your common factor. So you set that factor equal to 0, so we would have a hole at x equals 0. Now we don't know the y value for that. I'll go through that in a minute, how we would actually graph it. We just have to identify that the hole would be in that little spot. It's just one point. It's a single little hole, like a little open circle right on the graph. So for this one, it'd be x minus 2 times x plus 2. So the common factor is right here. So this has to be taken out. Then you say, okay, x minus 2 equals 0. So here we would have a hole at x equals 2. This one's already factored. And you can see the common factor is right here. So again, would be removed. You would have to physically remove this from the problem, but you adjust it by saying, okay, my factor, and then we get x equals negative 3, and this would be where the hole is. A hole is different than an asymptote. It cannot be the same thing. You can either have a hole or you can have the asymptote. You're going to have the asymptote. You might have a hole, but a hole and an asymptote are two different things. So let's put all this together. The order in which you solve this is completely up to you. These are the parts that you're required to have in order to draw a nice graph. You can also use your calculator to sort of help you draw it. So if you're not sure what it's supposed to look like, put it in the calculator. I'm going to start with what it asks for, the x-intercept. So the x-intercept, if you recall, that means we set the top equal to 0. So x squared minus 5 equals 0. So x squared equals 5. So x equals plus or minus radical 5. Square root of 4 is 2, so positive and negative radical 5 are a little bit bigger than 2 and a little bit smaller than negative 2, right on the x-axis. The y-intercept, all x's equal 0. So we would have y equals 0 minus 5 over 0 minus 4. So we get positive 5/4, so that's up. This is actually a little bit misleading. This is actually the point 0 5/4. If you have a tendency to write everything the same, then your lines, you'll have a hard time knowing which one is a line and which one isn't. This is the point radical 5, 0, and negative radical 5, 0. Vertical asymptotes, these are lines. Vertical asymptote is you take the denominator, set it equal to 0. X squared minus 4 equals 0. So x squared equals 4, so we get x equals plus or minus 2. Now this is how you would write this. These are lines. So we're going to go, and these are real close to the points. We have positive 2 and negative 2. You can see that this one does not look like one we've had before. Horizontal asymptote. You look at the degrees. We have x squared over x squared. They match, so it would just be y equals 1. Again, also really, really close. Now, here's the weird thing about a horizontal asymptote. A horizontal asymptote does not need to be obeyed. A horizontal asymptote can be ignored by your graph. You're going to have to check on the calculator to be sure. Generally, the horizontal asymptote is ignored in the middle. So if you have a midsection like we do here, like in between these two pieces, generally that means that that thing is probably ignored in through there. So just so you're aware of that fun fact. And then, of course, do we have a hole in the graph? Do we have any common factors? Well, the top does not factor, and the bottom does. So we have no common factor, so we have no hole in the graph. So now use your calculator to help you draw this in, because it's a little bit weird looking. This section here goes like this. This section, of course, goes like this. And then the middle section looks like a parabola. It's technically not a parabola. It may be flatter on the bottom. It is some of sort of U shape, appearing like a parabolic curve, but this might actually be sort of flat through there.